Solids can be of different shapes. A thin wire, or a plate, or a cube. When a thin wire is heated, its length increases. This is called linear expansion. When a plate is heated, its area increases. This is called superficial expansion. When a cube or sphere is heated, its volume increases. This is called cubical expansion. Consider a rod of length L0. When it is heated through T degrees centigrade, the length increases. Let the final length be LT. The increase in length depends on three things. One, it depends on the original length. Second, it depends on the increase in temperature. Third, it depends on the material with which the rod is made. At 0 degrees centigrade, let the original length be L0. On heating up to T degrees centigrade, the length increases to LT. Now what is the increase in length? LT minus L0. As I said, the increase in length is proportional to the original length. It is proportional to the rise in temperature. Therefore, we can write both together as LT minus L0 is proportional to L0T, or LT minus L0 is equal to a constant into L0T. The constant alpha is called coefficient of linear expansion. From this we can write alpha as equal to LT minus L0 divided by L0T. When L0 is equal to 1 and T is equal to 1, alpha becomes equal to LT minus L0. That means the coefficient of linear expansion of a material is the increase in length, of a rod of that material of unit length when its temperature is increased through 1 degree centigrade. Let's compare linear expansion, superficial expansion and cubical expansion. Consider a rod of length L0. At 0 degree centigrade, let the length be L0. On heating it through T degree centigrade, the length becomes LT, and therefore the increase in length is LT minus L0. As we know, the increase in length is proportional to the original length L0, proportional to the rise in temperature T, and writing it together, LT minus L0 is proportional to L0T. LT minus L0 is equal to a constant alpha into L0T. Therefore, alpha, the coefficient of linear expansion, is equal to LT minus L0 divided by L0T. Coming to the superficial expansion, consider a plate of area A0 at 0 degree centigrade. At 0 degree centigrade, area is A0. At increase the temperature through T degree centigrade, the area becomes AT. Increase in area is AT minus A0. As we know, the increase in area is proportional to the original area. It's proportional to the rise in temperature. Writing it together, the increase in area is proportional to A0T, or AT minus A0 is equal to a constant beta into A0T. The constant beta is called coefficient of superficial expansion. Beta is equal to AT minus A0 divided by A0T. Similarly, cubical expansion, consider a solid of volume B0 at 0 degree centigrade. At 0 degrees centigrade, volume is V0. Increase in the temperature through T degrees centigrade, the volume becomes Vt. Increase in volume is Vt minus V0. As we know, Vt minus V0, the increasing length is proportional to the original volume, proportional to the rising temperature. Writing it together, Vt minus V0 is proportional to V0T, or Vt minus V0 is equal to a constant gamma into V0T. Gamma is called the coefficient of cubical expansion. Gamma is equal to Vt minus V0 divided by V0T. The relationship between alpha, beta and gamma is alpha is to beta is to gamma is equal to 1 is to 2 is to 3.